Welcome everyone. So in this session we will talk about end-to-end work forecasting workflow. So the goal is simple. I mean, we will take a time series data, understand it, we will prepare it, and then we will try various forecasting models. So we are going to use Arimax, Prophet, and LSTM for this session. Okay, and we'll see. I mean, how things work. So I hope in first few videos you might have learned about different things related to time series. Because of limitations of time, we didn't go deep into these models, but I'll show you in this session that how to use these models. The dataset which we have used for this session is Tata Motors Limited data. Okay, which where we have data from early 1995 till August 2025. So these are the columns available in this dataset. Here, if you see, we have date column. Date column simply represents the date. Okay. And here you see, I mean, time series always need a proper time index. So this column becomes very important for our data. Okay. Next, we have symbol column. In our case, it is same for every row since all entries belongs to Tata Motors only. Okay. Then we have price related fields like open, high, low, and close. Right. So these columns shows the movement of stock during each session. Open shows like where the stock opened, and then high, what is the maximum high on that day, what is the low of value lowest value on that day, at what price it closed. Okay, all these things are there. Okay, then yeah, previous closed, like at what price that stock closed on the previous day. Okay, and then we have volume. It simply says how many shares were traded. Turnover tells us, yeah, turnover tells us the total value of those trades in rupees. Then VWAP gives us the volume weighted average price, which traders often use to judge the quality of a price move. Okay, let's not go deep into these things. So just take it like a, yeah, these are some features are there. Okay, which you can will be seeing if you have traded, or I mean if you are interested in stock market and all, then you might be aware about these features. Okay. Yeah. So yeah, here, yeah, daily percentage trade simply counts the number of executed orders. Then we have daily percentage return, cumulative return percentage, moving average 20, moving average 50. Okay. So all these things are there. As I said, our aim is to use this historical pattern to predict the future movement of prices. See, just to give you some idea, see, let's clarify some simple terms which we are going to use here and there. Trend simply means long-term rise or fall. Seasonality means repeating patterns, and noise means sudden unpredictable move. Okay. The techniques which we are going to use in this session means uh, Arimax, LSTM, and Prophet. Yeah. See, yeah, here we have written Arimax. See, Arimax, just I'll give you the brief overview of all these things. Arimax is a time series method that simply learns pattern in past values. Okay. And you also use it some extra features to improve the prediction. Okay. And then we have LSTM. It's a type of a neural network that is designed to handle this sequences. It remembers information for longer period, which makes it suitable for financial data, especially where old trends can still matter, right? Okay. Yeah. And then we have Prophet. It's a forecasting tool. It is designed to handle long time series with trend changes, seasonal patterns, all this. Okay. And yeah, I think that's a rough idea about these models. Let's do the setup. First, we will install required libraries, and then we will load our data sets. All right. Hopefully, after this, once we run this cell, then we have to start. Yeah, wait for it to complete, and then maybe in the meantime, let's talk about these things only. So you see here, what happens in Arimax is that it breaks data into auto regression, integration, and moving average parts. Right here, AR simply represents auto regression, then I simply represents integration, MA is for moving average, and then X is for exogenous. All right. So use typically it works well when the series has clear structure, and also outside factors are there which plays a role. Okay. If the outside factor doesn't play any role, then yeah, you can, instead of Arimax you can go for Arima. All right. And then if you see LSTM, it simply reads the data step by step. It is flexible and capture pattern that classical model may miss, right? Because it's obviously it's a DL model. And here if you see the profit, no, see it simply separates the data into trend, season effect, and holiday effect, which makes it easy to interpret, right? So if you see, this one works well when the data has missing dates or sudden shifts also. All right. Okay. So our, yeah, setup, yeah, this has run. So let's restart the, okay. Yeah, we have started it. Now I hope things will work. So yeah, let's load the data set and let's load the important library. It is taking time. Okay. We have loaded the dataset. I have given the link of the file. Okay. And then, yeah, we use the URL to load the data. All right. Let's see few starting tables. Okay. So these are the table. These are the columns available in our dataset: date, symbol, open, high, low, close, previous close. Okay. And then volume, turnover, VWAP, trades, daily returns, moving average 20 and moving average 50. Then let's see how many samples we have. We have 7,804 samples. Okay, and 15 columns. All right, let's see the info of this data set. I mean, what all things are there. So we can see that we have these 14 columns, and most of the column values are float type only. Only volume is in integer, and then unnamed 0. This is also in integer. So see, this unnamed is nothing but the row. I mean row number. All right. So we will remove it because typically when you use time series data, no, it's good to use date as an index. Okay, so that we will see. Let's see if we have any null values or not. Okay, so here we can see that in the trades column we have 4187 null values, and then in moving average 20 we have 19 null values, and moving average 50 49 null values. It is obvious because moving average 20 simply takes the average of I mean recent 20 price. Okay, recent 20 days price. And similarly, the moving average 50 takes the value of recent 50 days, yeah, most recent, or you may say previous 50 days average price. So that's why for first 49 day, like when the date would have started now from one, I mean, in 1995, for first 20 days, first 19 days, there won't be any moving average 20 value. And then for first 49 days, there won't be any, I mean, moving average 50 value. So it will be 9. All right. So what we are going to do, what we will be doing is that let's remove these first 50 values. Okay. So that we don't see any null values. Okay. We have enough sample. So let's move to the parsing part. So what we are going to do is that first let's convert date to the date time format, and then let's sort the values. Although the dates were sorted, but still, just to ensure everything works fine, we can do this. All right. And then we will drop this column unnamed. Okay. All right. And we what we have done is that moving average 50 values, if there is any NA values in this column, no, we are going to remove those rows. Okay. And so if we have removed MA 50, then obviously that MA 20 would be also removed, right? Because it's sorted, right? Let's see how many null values are there now. So we can see there are no null values in MA 20 and MA 50. So only null values are present in trades column. Okay. Yeah. Let's start with the some quick EDA. So what we will be doing is that we will draw a line chart of the closing price. Okay. And see, let's run it. So what we have done is that we have drawn the line chart for this closing price, and then we have created a new column named return, which will show the percentage change on that day. So here if you see the variation of this data, is something a variation of this price from 1995 till 2025. You can see the, I mean, it is fluctuating a lot, right? So we got a shape of like this, and then if you see the daily returns, which is nothing but the today's price minus previous day's price upon today previous day's price. All right, which is giving us the percentage change. We have this method, so I have directly used this one. So this one is giving me a graph like this, right? So except this date, this particular date, the percentage change is not much. I mean, it's in a stable state. All right. Mm, so now we have seen the variation. Let's split the data set into 80-20 so that we will use 20% data for prediction, okay, as a test set, and on the remaining 80% we will train our models, right? So here what I have done is that I have created variable name split point, which will simply take the length of the data set, and it will save the 80% of this. So that way split point will save the 80% value of that total number of rows, right? So using this, we have splitted our data set into train part and test part. You might have seen we do not want any shuffling here. So that's why we have directly taken the maybe yeah, the old 80% values for training and the remaining 20% value for test data part, right? So here you see I have run this cell and I can see the train starts at 13th March 1995 and trace data starts from 29th July 2019. So from 1995 till 2018, we have the we will use them as a training data, and from 2019 we will till 2035 we'll use them as a test data. All right. Now we'll start with our first forecasting model, Arimax. You see here AR sim part means the model looks back at its own past values. I part means the model may take differences to make the series stable, and then MA part means it tries to correct errors from the past. And then X simply means it can take extra inputs like volume, calendar, if volume, VWAP, trades, MA20, MA50, etc. Right? And then we will also use auto arima to automatically figure out good parameter. This will save time. Okay. Let's start. We will start by building the exogenous feature table here. Okay. And then what we have done is that we have taken the list of possible columns, and then here we have converted all these columns into a float type, right? Then we have created uh, some new features which is calendar based. So here the day of week we have saved it as a DOW. It will simply show me us the day, number of I mean the number of date on that number of day of that particular week. For example, Monday will be one, Tuesday will be two, something like that. Okay, and then exog a month. This column will save the month into numbers. For example, first, second, third, something like that. Okay, yeah. So what we have done is that we have one hot encoded these columns and added into these exog features. Okay, and then we have created some lagged returns. Okay, some more columns like here return for lagged return, like return for last 1 day, return for last 5 days, return on last 20 days. Okay, the columns like this will be also act as an external features. Okay, and then what we have done is that we have used exog.fill and it to fill the forward fill and backfill the missing values, right? And then let's split this exog table into exog train, exog validation, right? Okay, now we have used auto arima to suggest the right orders of arima when exogenous variables are present, right? This tool simply searches through different combination and returns the one that fits the training data best. All right, let's see, this is running. Okay, once we will get the recommended order now, we will prepare the target series. Okay, okay, and then we will fit a Serimax model on this. Here you can see that, okay, I have already fitted it here only. Yeah, right. Let's see, it is taking time to run. So what will happen is that in this way, it will this model will learn from close price history and also the extra signal which we have created. And finally, we will forecast the next values, right, for the validation period using this matching set of extraneous features. Right, the predicted values will be stored so that we can compare them with actual values. We will plot the graphs also later. Right. Let's see, it is still running. Okay. Once this running will complete, we will plot a graph to see how we have predicted for the test data or validation data, you may say. Let's wait for this run to complete. Here we have saved. Okay, we have since we already, okay, we are getting the, so suggested ARIMA order is like 213. Let's run this one also. Once this one will complete, then this. So here we had the test dates. So what I'll do with it, I'll clear all outputs so that you don't see, we won't see the output in advance. So here, yeah, we have got this. So you can see that the test dates starts from 29th July 2019 and it ends at 19th August 2025, right? So the last date which we have in our data set is 90th August 2025. So let's plot it and see what type of graph we are getting. So here what I have done is that in this code you see, I mean the previous training data I have represented as a gray color, and then actual values I have represented in yellow color, and then Arimax forecast is in this green color. You can see, I mean it is very much close to the real value, right? So I mean, but still, just to ensure the exact value, exact performance, what we can do is that we can create our evaluation matrix. So here we have created the evaluation matrix where we have mean squared error, root mean squared error, R2 score. We'll see so that we can compare the performance of various models. All right. Yeah, so you can also go through walk forward validation. So in this way, what will happen is that we will present at a step. Okay, we won't get all the prediction at one go. It will be like a live simulation kind of thing, like you can say. Okay, I mean, let's skip it for now. Then we have LSTM, right? So here LSTM, it is also called as long short-term memory. This is a powerful memory network that maintain memory of past sequences. Because of this, it is highly effective for non-linear time series modeling, right? So here what we are going to do is that first we will scale the data. Okay, here you see we are using closing price only. So we will scale this closing price between 0 to 1. Then we will create rolling input sequences for here. I mean this collab we have used 60 days to predict the next day's close price. Okay, and then we will, yeah, train this LST model. Okay, so okay, I think these things we have already kept in the. So let's run this one. Okay, it will obviously take time to run. So what you can do is then in such cases you can connect to a hosted runtime T4. Okay, I mean you just change the GPU type. Okay, just shift it to the T4 GPU or something like, okay, just shift it on GPU, which I have already done. So I do not need to do this again. So what we have done in this code now, first we have shifted our closing price value between -1 to 1. Then next we will what we will do is that we will simply define a sequence length of 60. This means the model will look at the previous 60 days to predict the next day. Then we create a helper function. Yeah, this function will simply look through the scaled series and builds these sequences. Okay, And then for each position after day 60, the previous 60 values become the input and the next value becomes the target, right? So and then we reshape the input, okay, so that each sequence has the structure the LSTM layer aspect, okay. And then once the sequence are ready, we align them with the original dates. So the first target appears at the index equal to the sequence length, so we shift the date accordingly. And then we split our data into training and validation set, right? And we will also save the matching dates for the validation part so that prediction can be plotted correctly later, okay. So that we will do it. And now let's define a two layer LSTM model here. So what I have done is that initially I tried for one layer, okay, and then I removed it, okay. I tried for two layer. And what we have done here is that we have created a sequential model and then added the first LSTM layer with 50 units, right? This layer outputs the full sequence because return sequence is set to true, okay. And then we have added the second layer, LSTM layer with 50 units, which outputs only the final hidden state. After that, we have added a dense layer. This will produce one value which represents the next predicted close price. Okay. And then we have compiled the model with Adam optimizer and mean squared error loss. Right. And then we have what we have done is that okay, we will print the summary. Okay. And here you can see that we have added early stopping. So training stops when validation loss stops improving. This will simply help us reduce overfitting problem. Okay. Yeah. Here you see that when this training will finish, no, we will use the model to generate prediction. Let's see what type of graph we have got. Then we have just plotted this graph. You see the summary of this LSTM model is like this, and then the graph we have got like this. So the performance, if you compare of this model, here we have printed only 2020 to 2025. We just ignore the old values, okay, the training values. So you the see it is almost overlapping the real values, right? The blue line represents actual, and then yellow orange line represents LSTM forecast. So you can see, here you might not be able to compare it properly because in terms of numbers we won't be able to compare. We will so here we won't be able to compare it properly because okay, what we will do is that at the end we will compare all the model performance by using evaluation metrics like MSE and RMSE, right? So yeah, that's the second one, and then we have profit, right? So here in this profit, this is as I said, this is developed by Meta. It is ideal for business forecasting. Okay, because it decomposes the time series into a robust trend, multiple seasonality, and holidays effect. So here, what I had done is that first I tried with some uh, values, but I didn't saw good performance. So that's why I just commented it out and I used the default values for this model. Okay. So here you can see that we have say we are setting up the profit model. Profit expect the column names DS for the date, okay, and Y for the target. So that's why we have renamed the column name date as DS and column name close as Y. So then we have splitted the data into trend profit and validation profit. As I told you, like I'm using the default values for this model. I have removed this one. And then what we will do is that we will fit it. So here you see we are going to create a future data frame. Okay, this will simply tell Prophet how many future dates we want prediction for. Okay, here we generate as many dates as the size of the validation set and we avoid including the training history since we only want forecast for the validation window. Okay, let's run this cell so that in the meantime we get the values also. So here if you see what we have done is that, so we call predict on this future data frame. Profit returns a large number of table with many components. We take only the last two rows. So extract the y hat column which contains the forecast close price. Then we have evaluated the model using our helper function and then create a plot. Right? You can see this is the plot we have got for this prediction. Okay, see how closely the model follows the real values. I mean, it is not so close, right? So in our case, I mean, Prophet didn't work well. So now we will bring all three models together in one place and we will create a clean comparison. First, we will start with a new data frame. Okay, that stores the dates in validation period. Then we add the actual close price and the Remax prediction. Then next we bring the LSTM prediction. They come from a slightly different date index. So we create a small data frame with those dates and merge it using the date column. This keeps everything aligned. Okay, and then we will do the same for the profit prediction. We will build another small data frame with dates and forecast and merge it with the main table. Okay. And after merging all three models, we trim the table so that it starts from the first date where LSTM predictions are available. This avoids empty rows and keep everything consistent. Okay. Once this table is clean, we will plot the actual value with all three model predictions. Okay. So here each model will get its own style. So the plot is easy to read, but you see, we'll see how things works here. Let's wait for the graph to come. Actually, in the meantime, it gave errors, so that's why I had to restart the runtime. So that's why it is taking time to run. Let's wait for some time, then we will get the graph, all the graphs in one go. So at this moment, I can say that, see, if you ask me to compare these three models, see, Remax is a simple interpretable and works well when relationships are stable. Then this LSTM is powerful when patterns are complex, but it takes more effort. You can, I mean, I used two layers. You can go for more layers also. Okay, and maybe you can try various feature engineering for Remax also to get a better score. And then if I talk about profit, so see, it is easy to set up and it handles the seasonality cleanly. But in our case, it didn't work well somehow. I mean, we used the default version. I wanted to just give you the idea. So these are the areas for experiment. You can try out different exogenous features. Then you can work on the LSTM. Okay, I have to restart this session. So all right, we have got the plot. Let's see here. You can see this blue line represents the actual one. This orange dotted line Remax represents the Remax. Green dotted line represent LSTM, and this red one represents the profit. You can see, I mean, from this graph, it seems that Remax and LSTM is completely overlapping the actual values, and it has almost followed the exact price. So yeah, I have done is that I have printed few dates and the values which we have got using actual, I mean, which we have got using Remax, LSTM, and profit. So better comparison. For example, 16th October 2019, the actual value was 121.35, but what we have got here is at 120 rupees 32 paise. I mean, this is very close. And from using LSTM, we got 122 rupees, right? And using profit 236, which is very far from the real value. And then similarly for, you see, similarly for 19th August 120, then we Remax is 119 and LSTM is 122. Okay, so you can see, I mean, it decreased by 1 rupees and this one decreased by just some point values in points. Okay, so if you see, I mean, LSTM is not deviating a lot, but Remax deviation is bit higher than LSTM. and profit is very far from the real values. Okay, so these are the areas for your experimentation. You can try different exogenous feature, then you can work with LSTM architecture. You can play, you can do change the layers and change the lookback windows values. Okay, and then in the profit also there are a lot of scope. We have just used a vanilla model for profit. Okay, so you can change, you can go, look for seasonalities and change points. Okay, and then if you want to simulate it in a real time, no, so you can use walk forward cross validation for all models. Okay, so yeah, I think that's all for this session. I hope you learned something. Okay, okay.